a video which part is content and which part is advertising. Who am I? I finished my studies around 2001 in IST. I worked in the telecom industry since then, and CRM systems, then in mobile web at Sapo, and currently I'm doing systems architecture at NOS Inovação. I'm a parent of 3 children. The youngest was born this week, and I also do Aikido for sports. Well, picture this. You are just sitting down, and you are going to watch your favorite series that you recorded. But since you recorded it, you are going to having to skip some commercials or watch some commercials. So you're going to be really bored by this, and we want to fix this, okay? So what can we do about this? We can look at the video and try to detect where is the program and where in the video there's advertisement. So you can see that on the left corner you have the channel logo on a program, but in the right picture you're just starting to see advertising and you don't have the logo there anymore. So let's try to detect these cases. Okay. In Portugal, at least, when you want to play some advertising, you are forced to remove the channel logo. So how are we going to detect this logo on the video and then pinpoint the time where the content starts and ends? Okay. openCV has a lib, an algorithm, which is canny edge detection. Essentially, it looks at each pixel and the pixels around it to see if they have different colors, or if you turn the image in black and white, different shades of gray. And if it varies very much, it marks it with a white color or a 1. If it is not varying very much, then it's a 0 or black. What we can do to detect where the logo is taking lots of frames that are separated in time, and then you apply the canny edge detection and you add them up. And as you add them up, the logo, which is most of the times in the program, in the video, will start to becoming clear, okay? Because the ones stack up and the zeros will become shades of gray. So processing with some threshold, you might get something like this, okay? And then it's just a question of trying to watch where the logo might appear. The logo always appears in one of the 4 corners. So what we can try to look at is there are lots of pixels in one of the corners. Are they together or are they separated? And after some hours of video, the logo will be clear. Also, in this solution, I introduced some decaying. So the pixels, if they are not stimulated, they will becoming darker again. So if the logo changes, the algorithm adapts. Okay. But when we look at the matching of this logo, we have some clear matches like the one below, which give us 80% similarity. And we have the lower matches, which are in black. It's 3%, 6%. But we also have some that give a match that we are not sure if it's pub or it's program. So how are we going to mark the exact time? We're analyzing every frame. Here I only put one frame every 4 seconds to be able to analyze. But analyzing every frame, we integrate it over the time. So in here, we can see a queue that I built, which takes 1,000 frames. And on top, we can see you have 880 content frames, 119 advertisement frames, and then one content frame. So that's barely over 4 seconds of advertisement, which does not make sense. So we correct it, okay? Below, on where it says transition, it's because we detected over 200 frames with pub. And then it is almost like 8 seconds, and he marks it as a transition. There's the case that this may even, after 8 seconds, it detects content again. It can happen. It's integrated later on. This is the first layer of integration. And every time that the algorithm detects something like this, 119 advertisements in the middle of content, or the reverse case, or unknown frames, it tries to learn from it and adapt the limits where it considers what is advertisement and what is content. Here is one case where it changes, actual changes from advertisement to a program, and has one unknown frame in the middle that he cannot solve, okay? Because it's right in the middle of the intervals that were being considered, which was between 35 and 50%, and it gave something like 40%, so it didn't shift, and it will align to the next frame, the first frame of the content. After this, we have to cross the frames and the timestamps with the programs. So at the time of the change, he detected in the time between 5 minutes before the change and 5 minutes after the change, he detected 2 programs, one ending and one starting. So it will mark the event as a program start of the event that is starting. And then we just have to save these video bookmarks, which have to take in account the feed delay, the recording buffer that is being used, and it also does some outlier removals, like when the advertisement and content switch too fast. It just integrates that and does not consider that that switches. It's clearly something that is not being correctly detected, maybe because of overlapping colors or something like that. There are also cases that this is not working very well, like when programs are not announced on APG. He might align it, the program that is after the program that is not announced with the program that is not announced, or the reverse case. and some newscast that will end after the 5-minute buffers. He will say that it will end sooner, but that's not a really big problem because we detect the advertisements, and with the bookmarks we can just skip to the next content. The service will do output something like this, so it marks at this moment 4 types of bookmarks: when a program starts, when an advertising inside the program starts and ends, and when the program ends. And after doing some testing with real videos, this is pretty much what happens, and that's because the recording buffer is not always the same. It varies a little, starts a bit sooner or starts a bit later, but verifying the bookmarks, it did a pretty good job. It caught the 2 advertisement moments just before the program starts and just after the program ends. Okay, so how was this done? It was all created using Docker containers in the mindset of Linux, and each container does something really simple and just that. So the frame publisher, the only thing that it does is grabbing the frames, converting them to grayscale, reducing the size, and sending them forward. The logo detector just takes 1 frame from the queue every 60 seconds. It's configurable, but anything that makes sense. And we'll do the accumulation and then publishing the logo when he thinks that it has good quality, and then it will go and publish it from time to time. The logo comparer will read both the frames by the frame publisher and the logo, and we'll just send forward the percentage of the match according to the logo that it has at the moment, and with it the timestamps and other information. The stats analyzer will look at the stream of the matching and will produce if the frame is a advertisement, then pub, or a program. The EPG checker then takes the information from the stats analyzer, relates it with the EPG, and will then say what program it is, if it's a program start, a program end, advertisement start or advertisement end, and then after that the bookmark saver, which looks at the stream of bookmarks and will save them, but if it sees that the bookmarks are switching too fast, it then corrects them. It does this in real time, so first time it doesn't have any information for the program, saves it, and on the second one we'll compare if the time between the 2 bookmarks is too low, and if it is too low it just discards it, and it will do this over the time of the program. They communicate, all the Docker containers will communicate via Kafka, which is a fast message queuing, and works very well for these use cases, even with messages at 25 frames per second and about 300k kilobytes. I analyzed this either in live streams or in recordings. The feeds that I had were these, and I then watched the the importance of the channels that were being recorded and played on NOS. And the first 5 channels have 80% of the content of the sessions. Okay, so just targeting 5 single channels and 80% of the times that you play the content, you could skip the advertisements. And the next red dot marks the 10 first channels, which is 90%, and the third, the 15 first channels, which amounts to 95% of the sessions. Now, instead of looking at the content, instead of looking at channels, looking at the content, we have a similar curve, but much more fragmented. So to get 50%, you have to process 10 series. The first 4 will go a bit over 30%. Looking at the bookmarks generated and doing a small test, saving the bookmarks and trying to play from the bookmarks, the errors that I got were low, let's say. It was not really an error, it was because the buffer is not perfectly aligned. So when you press play, you start typically just before the program starts. You don't even have time to fast forward. Okay. On Sick Noticias, there was some problems because most of the times the buffer is not big enough to support the errors on the channel transmission. The channel starts the program before the recording buffer. So instead of starting the program at 1 o'clock, it starts the program like 2 minutes before, and the buffer is just 1 minute. So it just starts from the beginning, but it is not the beginning of the program, it's the beginning of the recording. When I test this against recorded files, it could be frame accurate, at least for all the files that I tested, which included channels with transparent logos, channels with just some lines on the logo, like Globo. Transparent logos are the Fox channels, for example, so it works okay. Then there's a thread going on at NOS, which we want to implement some recommendations at the end of the programs that we are watching from recordings or going back 7 days. So if you interact with the command after 90% of the recorded content, you may get a screen to ask you if you want to watch the next episode or something like that. But the error is too big, okay? The live streaming error was not, I only analyzed prime time here, but it was almost 100% on RTP1, and it was because an outlier on RTP1. There was a short news segment that started after the EPG ending mark, so it was not considered, and it was only on the end time, not on the start time. And yeah, it's on the start time it's 100% match. On the end time, it failed in that case. There's some limitations in this process. Some sport events will have the logo changing side. This could be processed by looking at the recording and generating the logo on the recording, and then parsing the recording again with the logo generated just on the recording, which is done, but it's not what we want to use on usual case. There are some events like in Fox which are not separated by advertising, so we cannot really mark them correctly. Sometimes they even skip the intro credits if they are the same program. And some events have some logos that keep appearing and disappearing, and I didn't analyze why, but I think that's because they put advertising in the show. They talk about brands, and I think the logo is removed in those cases. Some programs are not listed. I already talked about this. And some programs have short clips which may potentially generate wrong program and bookmarks. We are exploring even other vectors. Currently, we're trying to implement audio fingerprinting with some nice results, detecting and matching the program intros, which have the same music, and the program endings. And this could be additional info for marking correctly the program start and program end. Another things that are being explored is the OCR to detect program credits. It's difficult on newscasts because the letters are small, but for movies they work okay. And they would do two things. They would correct or confirm the end of the program, but would also prematurely say that the program has ended. You can jump out of here, choose another content if you wish. Okay, this was it. Do you have any questions? What the project is, we are using this project to detect correctly where a program starts and ends, so in your recordings you don't have to skip the advertising.
Is it for a personal video recorder? Is that
Yeah.
Okay. Thanks.
Personal video recording, or when you go back in time and play a content that has already been broadcast.
Okay. Thanks.
Yes. So you asked, okay.
You are recording the data to Kafka, but
Yeah.
how are you reading the data?
Okay, Kafka is working like a message queue. So you connect to the message queue and you publish messages. And in the consumption side, you just connect and read.
You read it from a database, HBase. How are you reading the data?
No, the data is read from the message queue.
Directly from the Kafka?
Yeah. It is fast. The message, by the way, is encoded with message pack. Okay.
There is no way to, instead of using image recognition, to know what program were you trying to record and know at what time there was ads?
Yeah, we know when the program starts. Okay, that's the EPG Electronic Programming Guide, but it doesn't always start at that time. Okay, newscasts, yes. Okay, they try to start at the correct time, but the other programs will slide either up or down, and because of that, any telecommunication, any TV company will add to the recording some buffer because of those fluctuations, and that's what you get on your PVR, personal video recordings. Yeah.
Are you sending every frame to the Kafka stream for processing?
Yes, every frame. But we have on the script an option to say a floating point number of skip frames, so it can skip any amount of frames per frame processed.
Okay, and with this current setup, what's the brain power that you are needing for this processing?
With the minimal VM on Azure, we could process 3 streams with the full stack of Docker containers with no problems. Running also the Kafka and Zookeeper, okay? The full stack, Kafka, Zookeeper, database, and database to store bookmarks, and Docker containers for 3 streams, no problem.
Okay, thank you.
Okay. Thank you. If you want to reach out,